Welcome to Bhagaskara Labs. In this session, we're going to explore the Application Load Balancer in AWS, also known as ALB. The Application Load Balancer is like the traffic controller of your cloud applications. It makes sure that every incoming request is directed to the right server, improving speed, reliability, and overall performance. But we don't just talk theory here at Bhagaskara Labs. We'll walk through the hands-on workflow step by step, from building the VPC, setting up instances, to creating the ALB itself, so you'll see exactly how it works in action. So stay tuned, because by the end of this video, you'll not only understand what ALB is, but also how to build and test it yourself in AWS.
So what exactly is an application load balancer in AWS? It operates at layer 7, the application layer of the OSI model, which means it can look directly into the content of each request. This allows it to route traffic intelligently, for example, based on the host name or even the specific path in a URL. An ALB also ensures high availability and fault tolerance. If one server fails, traffic is automatically redirected to healthy instances, keeping your applications online. It's also elastic and scalable. As traffic grows, the load balancer automatically adjusts to handle the demand without manual intervention. And because it's deeply integrated with AWS services, it works seamlessly with auto-scaling for capacity, WAF for security, and SSL/TLS for encrypted connections. In short, the application load balancer is more than just traffic distribution. It's a smart, scalable, and secure entry point for your cloud applications.
Now that we know what an ALB is, let's talk about why you actually need it. First, it can distribute traffic across multiple EC2 instances. Instead of one server handling everything, ALB makes sure the load is balanced, keeping performance smooth. Second, it improves reliability. If one instance goes down, the ALB automatically routes traffic to healthy ones, so your application stays online. Third, it lets you scale applications without downtime. As your users grow, auto-scaling works with ALB to add new instances seamlessly with no interruptions. Fourth, ALB supports flexible routing. For example, you can send /API requests to dedicated API servers and /app requests to web servers, giving you better organization and efficiency. And finally, ALB helps enhance security. With HTTPS termination and AWS WAF integration, it protects your application from threats while keeping data secure. In short, ALB isn't just a load balancer. It's the backbone of a reliable, scalable, and secure application architecture in AWS.
Now, let's move into the hands-on workflow of building an application load balancer in AWS. We begin by creating a new VPC and attaching an internet gateway. This gives us a dedicated network environment and a way to connect it to the internet. Next, we'll set up subnets and a route table. By creating subnets in different availability zones and defining routes, we prepare the network foundation for our application. Then we'll launch 2 EC2 instances and install a simple web server on each. By testing HTTP in the browser, we confirm both servers are running and accessible. After that, we create a target group. This is where our EC2 instances will be registered, so the load balancer knows where to send incoming traffic. With the target group ready, we now create the application load balancer itself. We'll configure it as internet-facing, select multiple subnets, assign a security group, and connect it to our target group. Finally, we verify the ALB connection. By opening the ALB's DNS name in the browser, we can see traffic distributed between our instances, proving the load balancer is working as expected.
Our first step is to create a new VPC. In the AWS Management Console, open the VPC service and choose Create VPC. We'll name it Demo VPC and set the CIDR block to 10.0.0.0/16, which defines the private IP address range for our network. This VPC will serve as the isolated environment where all our resources will run. Next, we need an internet gateway, which we'll name Demo IGW. An internet gateway is what allows resources inside the VPC to communicate with the internet. Without it, our EC2 instances and eventually our application load balancer would remain isolated and unreachable from outside. Once the internet gateway is created, we attach it to Demo VPC. Now, our network has a direct path to and from the internet, which is essential for testing our web servers and exposing the load balancer. Now that we have our VPC and internet gateway, the next step is to create subnets and a route table. Inside the VPC console, choose Subnets, Create Subnet. We'll select Demo VPC, then create two subnets in different availability zones for high availability. Public subnet AZ1 with CIDR 10.0.1.0/24 in AZ1, public subnet AZ2 with CIDR 10.0.2.0/24 in AZ2. By using two subnets in separate availability zones, our application load balancer will be able to balance traffic across multiple zones, giving us fault tolerance. Next, we need to configure a route table. Go to Route Tables, create Route Table, name it Public RT, and associate it with Demo VPC. Then, edit the routes to add a rule. Destination 0.0.0.0/0, target Demo IGW. This route tells the VPC that any traffic bound for the internet should go through the internet gateway. Finally, associate public RT with both public subnet AZ1 and public subnet AZ2. This ensures that instances inside these subnets can connect to the internet and be reachable externally through the ALB. In this step, we'll launch 2 EC2 instances using Amazon Linux 2. Each instance will be placed in a different subnet, one in Availability Zone 1 and the other in Availability Zone 2. We'll assign both instances to the same security group configured to allow inbound HTTP traffic on port 80. After they are running, we'll connect to each instance and install Apache HTTPD to serve simple web pages. We'll repeat the process on the second instance so both are set up identically. Finally, we'll test each instance directly in the browser using their public IP addresses. If both display their web pages, our servers are ready to be registered behind the application load balancer. With our web servers running, the next step is to create a target group. In the EC2 console, go to Target Groups and select Create. Set the target type to Instances and configure the protocol as HTTP on port 80. Then, register both EC2 instances so the load balancer knows where to send traffic. For health checks, we'll keep the default path /. This allows the load balancer to continuously verify that each instance is healthy and ready to serve requests. After creating the target group and registering our EC2 instances, the next step is to set up the application load balancer that will distribute traffic to them. In the EC2 console, go to Load Balancers and choose Create Load Balancer. Select Application Load Balancer as the type, since it operates at the application layer and provides intelligent request routing. Set the scheme to internet-facing, so the load balancer is reachable from outside the VPC. For listeners, configure HTTP on port 80 to handle incoming web requests. Then, select our VPC and choose 2 subnets in different availability zones. This design ensures high availability, allowing traffic to continue flowing even if one zone experiences an outage. Next, create a new security group with inbound rules allowing HTTP traffic from everywhere. This makes the ALB publicly accessible while still being secure. Finally, configure the listener on port 80 to forward requests to the target group we created earlier. With this setup, our application load balancer is ready to route traffic intelligently to our web servers. With the application load balancer created and linked to our target group, the final step is to verify that it's working as expected. In the console, copy the DNS name of the load balancer. Open it in a browser, and you should see the web page served by one of the EC2 instances. Refresh the page several times and notice how the requests alternate between the two servers. This confirms that the ALB is successfully distributing traffic across multiple instances, providing both load balancing and fault tolerance. And that's the complete workflow of creating and testing an application load balancer in AWS. We began by building a VPC and attaching an internet gateway, then set up subnets across different availability zones to ensure redundancy. After that, we launched 2 EC2 instances, installed web servers, and tested their connectivity to confirm they were working properly. Next, we created a target group and registered our instances before setting up the application load balancer itself. Finally, we verified that traffic was being intelligently distributed across the servers, ensuring both load balancing and fault tolerance. This setup guarantees that your application is highly available. If one server or even an entire availability zone fails, the ALB automatically redirects traffic to healthy instances, keeping your service online. At the same time, as your traffic grows, the load balancer and underlying infrastructure can scale seamlessly, handling more requests without any downtime or manual intervention. By implementing ALB in this way, you not only improve performance, but also enhance the reliability, scalability, and security of your applications in the cloud. If you found this tutorial helpful, please like this video, leave a comment, and subscribe to Bhagaskara Labs to stay updated on more hands-on AWS tutorials and cloud workflows. Thank you for watching, and we'll see you in the next video with more practical, step-by-step cloud guidance.